Okay, before we start doing examples with calculating trig functions and things like that, we have to talk about what's called the complementary angle theorem. So this just says that co-functions of complementary angles are equal. Okay, so what's a co-function? We haven't really talked about that before. So we'll talk about what a co-function is, then we'll talk about this theorem. So co-functions, there's three co-function pairs. So sine and cosine, that's one co-function pair because it's sine and then cosine. We also have secant and cosecant. Okay, that's another co-function pair. And then tangent and cotangent. Okay, so sine and cosine is a co-function pair, secant and cosecant is another co-function pair, and tangent and cotangent is a third co-function pair. So we can say things like the co-function of sine is cosine, or we could say it the other way around, the co-function of cosine is sine. Okay, so these guys are co-functions of each other, and these two guys are co-functions of each other, and tangent and cotangent are co-functions of each other. Okay, so that's all this means, co-functions. That's just what that means. Okay, so now remember what a complementary angle pair is. So two angles are complementary if they add up to 90 degrees. Okay, so co-functions of complementary angles are equal. What does that mean? Well, that means, so let's say we have an acute angle theta. So acute angle theta in degrees. Then what this theorem really says is that sine of 90 degrees minus theta equals cosine of theta. Okay. And also cosine of 90 degrees minus theta equals sine of theta. Four more here. Tangent of 90 degrees minus theta equals cotangent of theta. And cosecant of 90 degrees minus theta equals secant of theta. And similarly, secant of 90 degrees minus theta equals cosecant of theta. Okay. And then finally, cotangent of 90 degrees minus theta equals tangent of theta. Okay. So where does all this come from? Why is this all true? How's that useful? Well, let's come over here, draw a picture of a right triangle. Okay, so remember in a right triangle we have a right angle, and then let's say we have an angle theta over here. So this angle theta and this other angle up here, they're complementary, right? They have to be complementary because they both have to add up to 90 degrees. Okay, whatever this angle is and whatever this angle is, they both have to add up to 90 degrees. Because, remember, in a triangle, in any triangle, all three angles add up to 180 degrees. This one's already 90 degrees, so these two have to also add up to 90 degrees. Okay? So if this is theta, then we can just say this one is 90 degrees minus theta. Okay? Why is that? Well, because theta plus 90 degrees minus theta. Okay, so if this angle's theta, we can just call this other one 90 degrees minus theta, because if we add them together, okay, we can drop the parentheses, and then thetas cancel, and we just get 90 degrees. Okay? Again, because no matter what this is, this one and this one have to add up to 90 degrees. So if we're going to call this theta, we can just call this 90 degrees minus theta, because these two together have to add up to 90 degrees, because this one's already 90 degrees. Okay? So now that we've established that, let's label the sides of this triangle here. So here's theta, so this will be the adjacent side, so let's just call it A. We can call it whatever we want, but we'll just call it A. We'll call this B, and we'll call this C. So again, we could have called this A if we wanted, that B if we wanted, whatever, it doesn't really matter what we call the sides. So what is the cosine of theta? Cosine of theta is the adjacent side over the hypotenuse. Okay, the cosine of theta is the adjacent side over the hypotenuse, which is A over C. Well, what's the sine of this angle right here? Okay, what's the sine of this angle? So what's the sine of 90 degrees minus theta? So remember, 90 degrees minus theta is just another angle here, right? So what's the sine of that? Well, remember, sine in general is opposite over hypotenuse. Which side is opposite this angle? This side is opposite that angle. So the opposite over hypotenuse is A over C. Okay, so remember, when we talk about opposite and adjacent, we mean with respect to the angle we're talking about. So with theta, the adjacent side is A, but with this other angle, 90 degrees minus theta, the opposite side is A, because this angle is opposite this side in the triangle, okay? So notice these are the same things, right? Cosine theta equals A over C, sine of 90 degrees minus theta equals A over C, and that's what we expect from the complementary angle theorem, okay? Or really, that's pretty much why that's true. So it's pretty easy to see if you just draw a right triangle and you'll see, okay, sine of 90 degrees minus theta, that's opposite over hypotenuse, which is A over C, and the cosine of theta is adjacent over hypotenuse, and the adjacent side to theta is A, okay? A over C is going to be adjacent over hypotenuse then, okay? So the exact same reasoning can be applied to these other 5 here, so we'll just go through some of them. So let's look at the sine of theta. Okay, so sine of theta, sine of theta is going to be the opposite over the hypotenuse, which is B over C. Okay, now let's look at the cofunction of the complementary angle. Okay, the cofunction of the complementary angle is cosine of 90 degrees minus theta. So what's the cosine of this angle? Well, the cosine is adjacent over hypotenuse. This side is adjacent to that angle. So adjacent over hypotenuse is B over C. Okay, so notice that's the exact same thing. Okay, B over C, B over C. So sine of theta is the same thing as cosine of 90 degrees minus theta. Okay, that's what we see here when we draw this triangle. All right, we'll do this one here, and then we'll also express these in radians instead of just degrees. So let's talk about this third one, tangent of 90 degrees minus theta equals cotangent of theta. Okay, so let's say, let's look at this triangle again, and then let's take a look at cotangent of theta. Okay, what's the cotangent of theta? Remember, cotangent is adjacent over opposite, right? So the cotangent of theta, this is the adjacent side to theta, this is the opposite side of theta. So the cotangent of theta is A over B. Okay. Now what is the tangent, I'm kind of out of room here, what is the tangent of 90 degrees minus theta? So in other words, what's the cofunction of the complementary angle? Well, here's 90 degrees minus theta. Remember, the tangent is opposite over adjacent. This side is opposite the 90 degree minus theta angle, and this side is adjacent to it. So the opposite side for this angle is A, and the adjacent side for this angle is B. So the tangent of this angle is opposite over adjacent, which is A over B. Okay. So again, we see that cotangent of theta equals tangent of the complementary angle. So the cotangent of theta is equal to the cofunction of the complementary angle, right? Cotangent theta is A over B. Tangent of 90 degrees minus theta is also A over B. So cotangent of theta equals tangent of 90 degrees minus theta. These other 3 here can be shown in exactly the same way. So just look at the triangle, see what's secant of theta, and then look at cosecant of 90 degrees minus theta, okay, and so on and so forth. You can do the same thing with these other 3 using this exact same reasoning, and you'll see that it does work out to be true. I suppose I'll leave that as an exercise for you guys. Okay, so the last thing we want to do is, so this is if theta is in degrees. What if theta is in radians? Well, it doesn't really change the facts at all. We're going to change 90 degrees to pi over 2. That's really all that is. So if we have an acute angle theta in radians, okay, then what we're going to have here is sine of pi over 2 minus theta equals cosine of theta. Okay. So instead of 90 degrees, just pi over 2. So it's really exactly the same thing, and all the concepts are exactly the same. The reasoning behind it is exactly the same. It's just, you know, instead of talking about these angles in degrees, we can talk about them in radians, and it changes absolutely nothing, except how we measure the angle, which does not affect which, you know, it doesn't change anything about this. So this theorem doesn't depend on how we measure the angles. We can measure them in degrees or radians or some other crazy thing. But no matter how we measure them, this is always going to be true. Okay, cofunctions of complementary angles are equal. Okay, so cosine of pi over 2 minus theta equals sine of theta. Okay, so it's really all the same stuff, but we'll just go through and write them all out. Tangent of pi over 2 minus theta equals cotangent of theta. Also, we're talking about these in terms of acute angles, but this is actually true for angles in general, which we haven't really talked about yet. But we'll get to that later. But I just want to point out that for now, we only know this is true for acute angles because we're dealing with right triangle trigonometry, and that's just all about trig functions of acute angles. Okay? So cosecant of pi over 2 minus theta is secant of theta, and secant of pi over 2 minus theta is the cosecant of theta. And then lastly, the cotangent of pi over 2 minus theta is the tangent of theta. Okay, so what we have here is the complementary angle theorem. It says that cofunctions of complementary angles are equal. So remember, cofunctions like sine and cosine are cofunctions of each other, and so on and so forth. So if theta is in degrees, then that just tells us this. If theta is in radians, then that tells us this instead. Okay, but these two things really say exactly the same thing. Just here we're measuring angles in degrees, here we're measuring in radians. So we're also going to use these facts here to help us evaluate and calculate some trig functions in the upcoming examples. So that is the complementary angle theorem.